Good morning, everyone. Hope you can hear me well. My name is Mircea, and it's a great privilege to be here in front of you today and to be sharing with you our automation story at DigitalOcean. Our journey began a long time ago, and as we are going to see in a bit, we tried to automate as much as possible from the ground up. This is our mindset since the beginning. Before continuing, I'd like to take a moment to thank Chris and Scott for inviting me here, as well as the entire team behind the Network Automation Forum and making this possible and making sure everything went smoothly these days, so thank you. And also in preparation of this talk, going step by step to make sure everything works great. I was really impressed by your work, guys. About myself, I've been sick this week, so if my voice sounds like a rake on a rough surface, I apologize for that. I try my best to recover this week. Unfortunately, I didn't get there, but I will do my best to speak as clear as I possibly can today. I've been 5.5 years at DigitalOcean. Previously, I've been at Cloudflare. I gained experience at CDN, and a service provider and enterprise environment, and also as a research and teaching assistant at an important university. Looking back, I can say I have an experience of over a decade, specifically focused on the network automation. And as we're going to see in a bit, I'm a big believer in open source, and our implementation at DigitalOcean is vastly based on open source software. DigitalOcean is a cloud provider that offers different services, virtual machines. We call them droplets. Everything has an aquatic theme. Kubernetes, luckily called just Kubernetes, GPUs, and so on, all being powered by a pretty large global network. The vast majority of our network is concentrated in these 15 points distributed globally in 15 data centers we have to maintain. But we also have a pretty large global backbone that interconnects all these locations we have. All in all, to keep the lights on, we have to manage about 10,000 network devices, and this can only be done using network automation. Today, I'm going to present briefly some tools that provide us the data. I'm going to speak briefly about Netbox, Pinning Manager, and IRRD. Moving on, we'll be looking into our configuration management approach and how all these tools presented previously, they all integrate together. Monitoring is a super important aspect of every network, of course, but how we can use that data to make intelligent business decisions is also equally important. And at the end, I'm going to speak briefly about AI. Everything is AI today, right? And we'll be looking into how AI actually impacts our network operations. That said, let's go ahead and speak about Netbox. I know what you're thinking, yet another presentation of Netbox. I will just touch it briefly, even though everyone knows about Netbox. It would be a stretch to say otherwise, right? And Netbox, I'm starting with it because it plays a fundamental part in our infrastructure. Everything evolves around Netbox. But I'm starting with it because chronologically, it was our first major milestone in our automation journey. It has been created about 8 years ago as an internal project that was eventually released to the public as an open source project. I'm not going to insist too much on it. We all know it. It's great. We love it. And the idea is that if you start your automation story today, you probably don't need to reinvent another IPAM. We can probably just use Netbox or whatever else. There are many choices today. And if they don't do what you need, because they are all open source now, you can contribute back to the community and give something to the people that have built it. Our automation story starts actually before the physical network exists. One of the most awesome features in Netbox is called Netbox script. We as the name might suggest, scripts are just a free-form Python script that allow you to interact dynamically with the data and create data in Netbox. Some time ago, someone asked me what's the most difficult task that I find in network automation, and what I said back then, and I continue to believe so, is that getting the data right is the most difficult task in network automation, and you can't get it right if you do it by hand. In this screenshot, we have one of our favorite netbox scripts that generate all the virtual representation of infrastructure when we extend capacity in one of our data centers, when we create new zones and so on. From the UI of Netbox, we select the site where we want to create these racks, the zone and the specific location, the type of the racks, the number of racks, the type of out-of-band leaves and spine switches. And when this script is being executed, it's going to create in Netbox for us all the racks, all the devices that we have there mounted into the racks, together with all the IP allocations with the PDUs and the power feeds, console servers, everything else that provides the actual representation of how the network is going to look like. So that's the first step before we actually have any devices physically. And speaking about data accuracy and getting the data right, sorry, it's pretty rough. The question is, your data might sleep for one reason or another. And the question is, how can you know that? And the answer is, again, Netbox. In Netbox, there's also something called reports that I think in latest version have been merged together with the scripts because they are essentially the same. They offer a programmatic way for you to grab or create data in Netbox. And using the scripts, you are able to, or reports, you are able to go through this data and validate it against your own requirements. We have different types of reports, such as duplicate, to check if we have duplicate loopback IPs, management IPs, checks our inventories against a list of serial numbers, or different other checks on internal or external prefixes. One such report is the prefix validation report that goes through what the prefixes that we announce on the internet and checks if we have a valid RPKI row created for those. Practically what the script does, or report, it goes sequentially through all the prefixes we identify in a certain way. Specifically on the prefixes that we want to announce on the internet, we apply a label that says announce, to announce it publicly, and goes through all of this and checks it against our sources to ensure we have a valid RPKI row. And the same goes for RIDB prefixes that should be synchronized upstream. And as you see, these are important for data integrity, not only for our internal use, but also for external use to make sure that we are good internet citizens and manage compliant. The other tool that I particularly like is Peering Manager. It's somewhat similar to Netbox in the sense that it is a pillar of data. It provides you the data for external connections. It can be IX, PS, PNIs, transits, and so on. This project is so underrated for some reason. I don't really understand why. So my ask today is go to that page, to peering-manager.net. That is going to take to their GitHub page. And please give them a star because this project deserves so much more. Another tool that I've been using at DigitalOcean for 4.5 years, I think, it's IRRD. But the truth is that we've all been using it for a lot longer without knowing it, perhaps. When you execute a whois request to RDB, this is what they are using behind the scenes, actually. And this is what we have deployed internally to have an internal whois server that is mirroring and caching for our internal use different sources from IRRs such as RIPE, APNIC, or providers such as Entity. I'm going to expand more on this later on how we specifically use this tool in the next section when we'll be looking at our configuration management approach, and then we are going to see how all these tools are being integrated. We can't talk about network automation without speaking of configuration management, and for that we use an open source tool called Salt, otherwise known as SaltStack, although SaltStack is the name of the company that was producing this project, now has been rebranded as the Salt project to avoid any confusion. We've been using for about 6 or 7 years, so actually before I joined. Why Salt, you may ask? As many networks, we have a mixed environment. We have a large variety of device roles from many different manufacturers, starting from the PDUs and console servers, continuing with the leaves and spine switches, and up until the edge of our network. We need to scale well. As I mentioned, we have about 10,000 devices that we need to manage, so Salt has been tried and tested already in many large environments. And part of our daily operations, we have to deploy configuration changes on part of our network, and sometimes even against only in the entire fleet. And for that, we also need orchestration and event-driven operations. Our configuration changes frequency has increased quite a lot lately, and we'll see it towards the end of this talk. And there's a very good reason for that. It's something related to AI. Salt also has many integrations out of the box, and if not, it's super easy to extend it into your own environment. And we also have a native REST API that we actually use internally to provide other teams, not just the network team, with an API that they can hit it and perform different operational configuration changes without giving them access, full access to the network. Before moving on, I want to make sure that this is not misunderstood. Don't focus on the tooling, focus on the methodology. We focus too much on the tooling in our environments, unfortunately. We are using Salt because this is what works for us, but everyone should be using whatever works best for themselves. Evaluate and make sure you make the right decision, not because someone told you to use the tool X or Y. And in fact, at DigitalOcean, we are also using Ansible and Chef for some particular operations. In fact, we are only lacking Puppet, so they have all 4 of them. To understand our challenges with using Salt, let's have a quick look at the topology. It's the typical hub and spoke. We have one master. Can also have multiple masters that manage these things called proxy minions. They are just some services or processes that are running anywhere. Can be a virtual machine, Docker container, whatever. And they connect to the network devices over the channel that the device supports. Can be netconf, HTTP, SSH, screen scraping, GNMI, whatever. And these proxy minions maintain a connection, and there's one proxy minion allocated per device. And that means a bit of a problem at a certain scale. The way we have deployed these proxy minions are, we have deployed them as Docker containers, in Kubernetes clusters distributed globally. In every geographic region, we have at least one Kubernetes cluster. And in that Kubernetes cluster, we have the proxy minions deployed that manage the devices in that area. However, we only have Docker containers for the proxy minions for only about 35% of our network. It's still a pretty big number if you think about it, considering our scale. But everything has a price, and this is the price paid to take advantage of all the benefits presented previously. Going further, we'd like to move these proxy minions, or some of them, on as close as possible to the actual network devices. Some platforms, such as Arista, they allow us to deploy the containers directly on the box. So our goal in the future is to distribute this load even further and deploy the container as close as possible. I've mentioned we have proxy minions deployed in Kubernetes only for 35% of the network. But what happens with the rest 65%? For that, we had to craft ourselves a plugin called Salt S-Proxy that comes on top of Salt. And instead of having those proxy minions that maintain the connection alive and they are continuously running somewhere, this Salt S-Proxy initiates the connection whenever you execute a command, perform the task on the device, operational configuration change, return you back the output, and then terminate the process at the end. This is another open source project that we have created and maintained. And if you have any feedback, if you come across it, definitely let me know. Now, whether we manage a device via proxy minion or a Salt proxy, it doesn't make any difference whatsoever, because when someone executes a command, the command is being executed transparently, regardless on the flavor of how we manage this that device. Let's have a look at how the tooling integrates together. For example, at the edge of our network, to configure a router at the edge, we need at least these 3 pillars of data: netbox, peering manager, and IRD. Netbox, of course, gives us the details of the device, interface details, and other kinds of internal connections with other devices. Peering manager, of course, with external connections for IXPs, PNIs, and transits. And IRD, we are using it to build the prefix filtering based on the what the networks are supposed to be announced to avoid accepting illegitimate announcements. All these 3 are integrated into Salt, and it doesn't make any difference, again, of how we manage the actual devices or whatever flavor of Salt proxy minion or super proxy. A colleague of mine has expanded on this specific topic on the prefixes filtering at the edge of our network. If you go on the YouTube link on the left-hand side of the corner, you'll find his presentation at Nanog about 2 years ago. Well, something that people ask me many times is how we resolve ZTP, or zero-touch provisioning. And it couldn't be simpler, really. Here again, we meet Salt, that retrieves the list of staged devices from Netbox. For those of you who are not entirely familiar with staged devices in Netbox means, if there's still anyone, in Netbox, every device has a status field, which can be one of the following: active, staged, decommissioning, offline, and so on. And staged is one of those, and Salt retrieves the list of these staged devices, and for each of them is going to generate the configuration and dumps it into a file from where it's served by an engineering server to make it available as for HTTP requests. The same time also generates the configuration for the DHCP service, and when a new device is attached to our network, because it's in amnesiac state to follow the naming convention of some vendor, it will initiate the DHCP request, and the DHCP server responds back with the DHCP list with the IP address that is being allocated, of course, together with some standard options, I think 67 and 68, that provide the location from where the device should be gathering its initial configuration and a firmware image. I remember a few years ago there was a startup company eventually acquired by a major vendor, now a printer manufacturer, that was selling just this. This was their product, a glorified DHCP server practically, for a very expensive price. But the good news is that you can build this yourself using open source tooling and save some millions of dollars. All right. I could spend hours talking about our automation and configuration management approach at DigitalOcean. Now let's move on to something more exciting about monitoring global network. Excuse me a bit. Our monitoring approach is based on Prometheus, and luckily, internally, we have a team that manages Prometheus for us, and so we don't have to do it. However, there are still parts that we have to maintain ourselves. Prometheus, for those of you who are not entirely familiar with it, is an open source monitoring system that has a dimensional data model, time series database, and modern alerting approach. And this Prometheus practically executes periodically requests to hundreds or thousands of HTTP endpoints that present the data in a text format, having a very standardized format. Prometheus scrapes that data, that's the term, practically just reads the body of that HTTP response, and stores it internally in a time series. In our case, we have this called exporters. Those HTTP endpoints I mentioned earlier, they're called exporters. They connect to the devices, for example, via SNMP or netconf and so on, and grab the data from the devices and expose it as the result as an HTTP body. Excuse me. Right. In our case, we run these exporters in Kubernetes, again deployed regionally. And another important aspect is that every HTTP request must be unique. Every device has its own story, right? So for that, we need to have a targeting system to identify that, hey, I'm going to retrieve the data from this device or this device. In our case, we have this called service discovery. That's the name in Prometheus language. That executes periodical requests to Netbox, retrieves the list of devices that we want to monitor, and feeds that to Prometheus. So Prometheus will know, I'm going to now to get the data for this device and now for this other device. Unfortunately, we don't have any streaming telemetry yet, but hopefully we are finally about to get to that. Here is a visual representation of what I described earlier. Prometheus makes the requests to these exporters, grab the data via SNMP, netconf, whatever else, and make it. And Prometheus stores the data in its own time series. From where you can do two things typically. We can have a nice dashboard based on this data, for example, using Grafana, or you can define some expression, some alerting system that based on those metrics, and those metrics and those expressions can be simple or as complicated as it can be. That when they match, Prometheus is going to generate an alert and sends it to this other project called Alert Manager. Is a sister project developed by the same Prometheus community. And this Alert Manager is used for deduplicating, aggregating, and routing the alerts to the appropriate channels where you want to see these alerts. In our case, the place where we want to see these alerts is Alerta, another open source project. Pretty simple one. It presents the alerts in a colorful palette like that, based on the severity level of the alerts being received from Alert Manager. And this tool allows a lot of customization, has its own flaws, but we generally like it. And one of these customizations that it allows, when we use it externally, hope you guessed, it's based using Netbox. For example, if we have an interface down alert or interface flapping, just by looking at this alert through this integration with Netbox, we are able to see exactly what's the name of the interface and device on the other end of the cable, and so on. All right, and now you have this pile of alerts, right? What do you do with them? Typically, you go and look at the alert and join and log into the device and do something manually about it. That doesn't sound like a lot of automation, does it? And our approach is slightly different. Alerta has this feature that besides receiving the alert and displaying it on that dashboard, it also puts the alert event on a RabbitMQ message bus. Let's have a look at the global picture. Prometheus scrapes the data from devices exposed via SNMP and netconf from the network device, sends the alert to Alert Manager when the conditions match, and which fire the alert to Alerta. Alerta puts the event on the RabbitMQ message bus, from where it's picked up by Salt. Salt is going to, through its own event-driven engine, will look at this alert and will inspect it, and using different other requests, for example, to grab data about the device or interfaces and so on from Netbox. We'll also go eventually to check what's on the switch. For example, if we have an interface flapping or interface down, we'll also go and look at the switch. Hey, is this interface really down? And if so, what's the cause of it? We'll check the optics level, temperature, and other sets of important details. And using these two pieces of data from the device and from Netbox is able to intelligently take an action that is operational or configuration change, and potentially even create a Jira ticket automatically. And this is how we can build a closed loop event that allows you not to action the alerts manually. I think it's very important, and it's about time that for us we focus not on just these pieces of automation individually, configuration management and monitoring, because they all should be tied together. Here's a quick example of a Jira ticket created as a response to one such event. For example, after an interface was down, Salt went on and checked some details on one of our devices. And as you can see, the reporter, I'm sorry, I don't have a pointer. In the right side of the screen, you can see reporter is the Salt NetDev, is our automatic bot that creates the tickets. In the body of the ticket, you can see also a bunch of other details from operational that has been collected that show to the operator what is being seen on the device with the details. And in this case, it requests the operator to replace an SFP on a device, and together with a bunch of other details that help the operator to perform the physical change based on the labels and the details shared there. Excuse me. Now it's time to move on to a different component, the last part of my talk. Just like in the previous part, I could spend hours expanding on our monitoring and approach. I hope that by the example I showed previously would inspire you to make the steps in this direction as well. And what I've showed, maybe it's sufficient for now to make an idea of what we have and where we want to go. Obviously, we don't have this sort of automatic actions based on the alerts for everything, but we aim to get there. And if not, even if it's not a fully automated action taken in response to some alerts, at least to offer a playbook that someone doesn't log into the devices manually and make some manual changes or to run some commands, at least to have a playbook that goes through in an automated fashion to apply changes or perform operational changes on the devices in a more automated manner. And now the last topic about AI and how AI actually impacts our network operations. It's a pretty exciting topic nowadays, and we'll see how AI actually affects us. To make sure that the terminology is well understood, we offer this called GPU droplets, which are nothing else than virtual machines powered by GPUs for heavy AI and machine learning workloads. And now they are in two flavors based on NVIDIA H100 and H100 times 8. The comparison between them is rather simple. NVIDIA H100 times 8 is really just 8 times the compute power of and memory of one NVIDIA H100. And why is that? The explanation is simple. These NVIDIA H100 are practically inserted in an almost regular server. They are just slightly bigger servers, 6 or 8 rack units that have exactly 8 slots for inserting these GPU cards. And when someone spins up a GPU droplet based on NVIDIA H100, practically they rent one of those cards, and someone spins up a GPU droplet based on H100 times 8, practically they rent that entire box with all these line cards. Each each of these GPUs has one network interface, and naturally, one server that has 8 slots for 8 GPUs will have 8 interfaces that are connected in a close topology or leaf spine, if you want, to 8 different leaf switches. Now, when someone creates a droplet based on NVIDIA H100, a VLAN is allocated to that customer, and VLAN is created on the leaf switch side. If someone creates based on NVIDIA H100, then because all the GPUs need to talk to each other, the VLAN is allocated per the entire box. And here comes the interesting aspect from a network automation point of view. Because that VLAN needs to be needs to be configured on all the 8 switches when someone performs an action. So to put it in a different way, someone creates a GPU droplet that translates to 8 different configuration changes on 8 different switches, right? Someone shuts down the droplet, that VLAN needs to be removed from 8 different leaf switches. Make that hundreds of customers with hundreds of virtual machines and see how many configuration changes are required. This could not be done without network automation. It's impossible. And now the question is, WTF, what the future is? I actually borrowed this title from Tim O'Reilly. I attended a keynote a few years back when he was releasing his book entitled Just Like That, WTF. And something that stayed with me since then is about embracing change. He gave this great example of the aviation industry, where at some point pilots were starting to fear they were losing their jobs because of the automatic systems that started to be enabled on the aircraft. But if you look today, we just don't have enough pilots. And that is specifically thanks to those automatic systems that made the industry safer, more reliable, and as a result, that increased demand. And it is exactly the same in the networking world. Now, I don't know if AI is going to change the world for the better, but definitely is going to have a huge impact on the way we operate networks. I gave this small example previously on how we built this GPU fabric. Don't focus too much on the actual implementation. It's a pretty rusty and rudimentary implementation, actually. It was done because the business came to us and said, hey, we need to offer GPUs to our customers, and we need to do that soon. Could we have done it without automation? No way. That's out of discussion. And what I want to say is, even if you don't have GPUs in your networks, you'll say, okay, that's not important to me. But AI comes with such huge demands in terms of capacity and compute power that they are going to have an impact on your networks. Excuse me. Because of this demand, if you want your business to stay relevant in the next 5 to 10 years, I would say, it's massive about time you start investing in automation, I would say. Maybe even less than 5 to 10 years. It's going to be impossible to manage networks manually anymore. And it's easy. The more you invest in automation, the more you'll be able to deliver features to your customers and be ahead of your competitors. And the same applies to my own employer, I have to say. It's not it's not like I'm here talking to you about a perfect environment that I have and teaching you something that from my experience. We also have to get better at that. Before closing, I just want to take a moment to praise some engineers that we've had at DigitalOcean across the years. Without their work, I wouldn't be here because they built it. talking about Jeremy, I won't make the same joke again. Zach, who's moody every day. Chip, the data marshalling guy. Antoine, Marcus, Stephen, Nancy, and Marcus. In fact, 2 of them are just over there, I think. And yeah, thank you guys for all the hard work over the years. To look back, I just want to have a look at what I've been talking about today. I want to make sure that network automation don't make this confusion. I heard it so many times. People came to me and said, you know, I have my network is fully automated. Okay, can you tell me more about it? Well, you know, I have this Jinja template, I render it, and that's it. That's not it. Automation starts before the actual physical network exists. It's a long-term process that starts before the actual network exists, when you configure it, how you monitor it, what decisions you make afterwards. It's so much more complex. It's a never-ending process. Your feature continuously will have new, your network will have continuously new features. It will never end. Full automation, or if you want to claim that your network is fully automated, it means you don't touch it manually at all. Personally, I'm not aware of any network like that. If you do, please come to me and I will learn something new. Also, focus on the methodology, not on the tooling. I've been presenting a bunch of open source tools that we use. It doesn't mean that you should use that. You should evaluate and try what's best for your own requirements. If I use that and I say so that tool X is cool, it doesn't mean it's true. You should use whatever serves your business requirements. And as we've seen, we can build also network automation using open source tooling. You don't need to, but one thing to make sure and keep in mind is that open source doesn't mean it's free. Open source can give you the start, but at some point a tool won't be able to give you everything you need. We gave that example with that Salt plugin, Salt as proxy, is really because Salt, the open source tool, couldn't give us what we needed, and you might have to do the same. It's not only about investing in buying the feature or a subscription, it's also investing in people to craft and add on or contribute to the open source space and give back to the community. And lastly, be ready for AI because it's coming. That's all I had to say. I hope you understood anything of what I said. Sorry about that again. And I'm ready to take some questions. Dinesh?
Good. As a fellow Salt user, I'm curious of your views on the viability of Salt as a platform for network configuration and automation, with all the upheaval that's been going on with both the VMware and Broadcom acquisitions, and they've lost a number of their core team. Tom Hatch has left. Curious on your views of the platform as being viable and whether you would recommend it to people just starting out in automation.
Tough question, really. I don't know. I've been watching it, a bit worried, to be honest. Because leaving aside if I use it or not, but I'm an enthusiast about that project. I've been using it for so many years. And I would be the same with any other project. If I would hear tomorrow that they are doing something similar with Chef or whatever, I would be equally worried. Yeah, it's not looking great. I hope things will start to get back to normal at some point. If not, hopefully some of the big guys, I don't know, Bloomberg, Cloudflare, will fork the project and will continue to drive it forward. I really don't know what to expect.
Hi Mircea, thank you very much for your talk. Is there anything you would do different if you would start again?
Yeah, many things. I don't even know where to start from. For example, I showed that dashboard with Alerta. I wouldn't use that project anymore, to be honest. It caused us more issues than it gave us back. They are, at this point at least, Okay, we are talking about some tools that have been adopted early on, many years ago, and continue developing around them. So it's a bit hard to say one day, okay, just give it up. But today, there are so many other options. For example, there's a project called Keep that I like very much, and I would use that for example. Other aspects haven't been covered in my talk today. For example, to build the metrics we have for Netbox, we are using something GraphQL instance that is in front of the Netbox database. Is based on Hasura, another open source project. And at this point, I wouldn't go back and do it the same way. In the meantime, Netbox offers now GraphQL, even though it's slightly slower than the Hasura that interacts directly with the database, doesn't go to the Django's ORM. But I would still use what's already there, wouldn't reinvent the wheel. So yeah, we've also did lots of mistakes.
Got one over here.
Could you talk in detail about how you use Salt to build those netconf and GNMI requests? And maybe what percentage of your network do you think supports those two protocols?
Sorry, can you repeat that question, please?
Yeah. Can you talk in detail about how you use Salt to build the netconf and GNMI requests to configure devices?
It's based on a third-party library called Napalm that I maintain. And Napalm for netconf specifically, in the context of Juniper devices, is based on the library maintained by Juniper, PyZ. So that's all.
And sorry, last one. What percentage of your network do you think supports those two protocols, netconf and GNMI?
Netconf, I would say 90% of the network.
I had a question. You guys seem to be great supporters of open source, and I really thank you for all the contributions. Really, it's amazing stuff. And we're doing great things because you guys have come before us and learn all these lessons. My question to you is, what is it in your management and your company that makes them so friendly to be able to use and produce open source, and how do you think that culture could be fostered in other businesses?
I don't know. I think I'm just lucky enough to, because we inherited that. It was from the beginning. It was like with an open source mindset, and it continued along the way. If we don't have that, I think the question is, I don't have that. How can I make my company be more to have this mindset? I don't know. I'm not good at changing mindsets. I'm also struggling with many things, obviously, that I don't know how to correct. That's the truth.
Have you ever given any thought, and maybe you don't have use cases, so maybe this is invention, or necessity being the mother invention, but have you ever given any thought to extending sproxy to be a Delta proxy minion?
Yes, I have evaluated Delta proxy, and it just doesn't work.
Oh, okay, fair enough.
In theory, it works, but it messes up. Each device should have its own set of grains, pillars, and so on. But it messes up. And for example, if the connection is lost with one device, because it's one process that manages multiple devices, it doesn't know by itself to restart the connection. I've run into many issues evaluating it. That's it. Thank you.